Good evening, guys. I'm audible. Okay, thanks for the confirmation. Okay, so let's start with our session today. So today, actually, I'll be discussing about the GANs. So how many of you heard of about GANs before? Anyone? Do you know what is GANs and all? Okay, no. Okay, so mostly I can see you're telling no. Like, did you see that kinds of videos there would be a person like fake person, he will be talking with that a new person face would be attached. Okay, like deep face, did you see like Barack Obama, Elon Musk, these kinds of video, like I think you can see from LinkedIn, right? uh, Guys, my voice is clear. There any issue? Okay. Okay, I will give more example, even I will show some of the application. Okay, but I just wanted to know how many of have heard of this GAN before. Okay, so that is why. Okay, no issue, let's discuss. Okay. Okay, so I'm sharing my screen. Just let me know once you are able to see. Share screen. Okay, is my screen is visible, guys? All right. Okay, so first of all, let me open my board. Let me write it down today's agenda. Okay, so today actually I'm going to discuss GANs. Okay, so the full form is the full form of this GANs is generative adversarial network. Okay, so GAN is nothing but it's a generative algorithm. Okay, algorithms. So far what you have learned, okay, so far you have learned about supervised learning, right? Supervised learning, I think you know. So in supervised learning, what we do, we give X, okay, and we also provide the Y. Okay, that means we give our input data. Okay, with that we also provide our output data. Okay, based on that, actually we try to, like, you can say, train a model. We try to get the relationship. Okay, then later on we are just you can say able to uh, make the prediction. Okay, on this trained model. Then I think you have something called unsupervised learning. Unsupervised learning. So in unsupervised learning, what you give actually, okay, you give just your X data. And as of now, I think you have learned the clustering, right? How many of you have learned clustering? I think if you know machine learning, so I think clustering you should be familiar with, right? Anyone? Okay. So in clustering, what you do, like basically, if I talk about, yes, grouping the data. Suppose you have some data here. Suppose there are some data. Okay, based on the data distance, what you do, actually you try to group them. Okay, suppose this is in A category and this is in B category. Okay, yes. Okay, but today the topic I'm going to discuss, it is also falls in unsupervised learning. Okay, unsupervised learning. Okay, but here we are not going to cluster. Okay, we are not going to cluster the data. Instead of that, what I will do, okay, what your GANs will do, it will generate the data. Okay, like by saying the name, I think you can relate. A generative adversarial network. Okay, so GANs is nothing but it's a generative algorithm. Okay, it can generate something. Okay, now what what it can generate? Okay, it can generate many things. It can generate image, it can generate videos, it can generate audios. Okay, it can generate text. Okay, how many of you heard of AI has written a story, AI has written a film story? Like, did you heard of these kinds of news before? Right? Okay, so this is like one kinds of GAN application. Okay, so here, based on the GAN, actually what they are trying to do, they are trying to generate some data. Okay, it can be image. Okay, it can be videos, it can be audios. Okay, it can be text. Okay, so basically here we also provide the input. Okay, input means, so see, first of all, let's understand what is the idea of the GAN. Okay, what is the basic idea of the GAN? The basic idea of the GAN is, suppose you have 1000 dog images. Okay, dog images. Okay, suppose this is your GAN model. So what you will do, you will just feed this 1000 dog images to your GAN model. Your GAN model will generate a completely new image for you, completely new dog image for you. Okay, dog image for you. So this image won't be exist inside the data you have provided. Okay, is it make sense, guys? What is GANs? So here you are not providing the output. Okay, instead of what you are providing lots of data. Okay, it can be image data, it can be audio data. Based on the task you will be defining. Suppose here I want to generate some of the images. Suppose I want to generate a dog images. So what I will do, I will feed a lots of images to my GAN model. Okay, my GAN model, okay, will see the dog images. Okay, and it will try to get the idea. Okay, like how dogs looks like. Based on that, it will imagine something. Okay, then it will generate some new dog images to me. Okay, Bhavya, like what you want to explain again? Yes, deepfake is an example of GAN. Okay, I will discuss about that. Just wait. Okay, see, GANs is nothing but it's a generative algorithm. Okay, generative algorithm. So it can generate data. Okay, as of now, you have worked on supervised learning, unsupervised learning. So in supervised learning, you basically try to put your X data, okay, like your X features. With that, you also try to put your Y. Okay, that means your output. Based on that, you do the prediction. Okay, after training. And unsupervised learning, I think you have learned the class training technique, right? So suppose you have some data. Based on that, you will be applying some distance formula and you'll be categorize that data, right? But in GAN is also inside the unsupervised learning. But here we don't put like Y, okay, like Y, that means our output data. And we also don't do the clustering. Okay, instead of that, what do? We try to generate something new data. Okay, suppose there is an example I showed. Suppose you have 1000 dog images. Okay, and now what you want to do, you want to build a GAN model. Okay, So that model would be able to generate completely a new dog images, okay, after seeing this 1000 images. Okay, suppose just relate with I mean with the human man, I mean a human being. Okay, so suppose if we see something, suppose if you show me 1000 cat images, okay, suppose I'm an artist, okay, you just show me 1000 cat images, then just tell me, just draw a completely new cat images for me. So would I be able to do? Just tell me, guys. Can I imagine in my mind like how cat looks like? Okay, I can sense like the ear, I can change the tail of the cat a little bit. Okay, that's how actually I can change the color of the cat. That's how actually I can draw the cat. Okay, what I want, okay, what I can imagine in my mind. Okay, so it's totally imagination. Just consider GAN is nothing but it's totally imagination algorithm. Okay, by imagining that thing, it can generate the data. Okay, now I think it makes sense, guys. What is GANs? No, it's not data augmentation. Yes, you can generate music also. See, here I'm suppose I have given the example with the image. Okay, suppose now you have 1000 audio, or you can say 1000 audio music. Okay, audio music. So audio is what? It's like a frequency at the end, right? It's a frequency. So you just feed this 1000 audio to your GAN model. Your GAN model will see all the 1000 audios. Okay, it will see the pattern, it will see the relationships, like how audio looks like. Okay, based on that, it would be able to generate a completely new audio for you. Okay, audio, or you can say music. Like nowadays many AI system is there, it can generate like new music, right? It can compose music, it can write a story, right, guys? Okay, I will tell you the real world example. Okay, now just tell me, did you get the idea like what is GAN all about? Okay, like what is the concepts of GAN? Okay, now I think you can relate like what is unsupervised learning, what is supervised learning. In supervised learning, like how it works, unsupervised learning, clustering, how it works. Okay, then in unsupervised learning, how GANs works. Okay, I think you can relate. No, don't consider paraphrasal. Okay, paraphrasal, it's a new thing. See, GAN is nothing but it's a generator. It can generate completely a new data. Okay, that data doesn't exist ever. Just consider that thing. Okay, now let me show some of the example. Yeah, so there is a blog, I got it. Okay, so I think you should be familiar with this website, machine learning mastery, I think. Okay, I'm sharing this blog with you. So here actually you can see some of the GAN applications. Okay, like before starting the GAN, I mean understanding. Okay, let me give you some of the application workflow so that you can get more interest. Okay, to learn GANs. So here, if you see, if you just go below here, generate photographs of human. Okay, I think you might see in LinkedIn or anywhere. Okay, suppose there were some GAN application, it can generate human faces, and this human actually doesn't exist in the world. Did you see this kinds of application before? See, this is generated by GANs actually, these images. Okay, see, completely real human face it has generated, but this humans actually doesn't exist in the world. Okay, this is totally based on the imagination of the GAN. So what they did, they feed lots of human faces, that model, they train the GAN. Okay, then after that, that GAN would was able to like you can say generate these kinds of faces. Okay, so there is a website I can share, like this person doesn't exist.com. Okay, if you just go to this website and if you just refresh, okay, if you just refresh, and you will see different humans. Okay, and this humans actually doesn't exist, this person doesn't exist ever in the world. Okay, can you trust? By looking into this person, he will see like, yeah, this person is exist, but basically this person isn't exist in the world. Okay, this is completely generated by GANs. Isn't it amazing, guys? See, what is the proof? You want the proof right now, right? See, if this person is exist, okay, somehow, so it would be totally coincidence, okay? But they can guarantee, okay, even it is proved by the research. So when they have implemented this thing, okay, like they already, you can say, showed like this person doesn't exist in the world. Okay, now again refresh this page, you will see another image. Okay, so this, I mean, ladies isn't exist in the world. Okay, but just see like how beautifully it has generated these images. Okay, it is completely realistic images. Okay, got it. So not only person, okay, not only person, if you see right hand side bottom, you will see a pop-up screen. Okay, here you will see some more example. Like, see, this is a style GAN. Okay, the name of the GAN is style GAN. So by using style GAN, actually you can generate like human faces. Okay, now here if you see, they're not only like human faces, you can even generate the cats. Okay, cats images. So I just click here, there is a cats is also there, right? Cats. Now this cat doesn't exist.com. Okay, it will take you, I mean, to this website, and just refresh here. So you can consider, okay, that kinds of cat I think you can see, but your GAN is like telling it is completely newly generated. Okay, now let's consider it is completely newly generated because it has been generated by GANs. Okay, but if you see, it is completely realistic. Yes, this kinds of face app I think you saw, like after 30 years how you will look like. Okay, this is also GAN application. Okay, now now not only this one, even there is a like chemical formula. Okay, chemical formula it has also generated. Let me show you. See, this is one molecule. Okay, it is generated by GANs. Okay, now see, nowadays actually on the GAN, actually there are many researches going on. So they're not only creating these kinds of I mean dummy application, they're utilizing these GANs in the medical domain. Okay, like there are many domains they're utilizing. Yes, Babia. Okay, see, this is one molecule and it has been generated by GANs. Okay, now again refresh, you will see another one. Okay, so this is the chemical formula. Okay, so not only that, you have many things here. Actually, if you see, just explore this website. See, the main motive of this GAN is like, if you, there are many kinds of GAN. Okay, now based on your task, suppose what you want, suppose you are interested in music. Okay, so what you can do, you can take a lots of music, you can train your GAN model with the music. Okay, later on, suppose, see, nowadays actually there are many musics. Okay, but you want to generate something new. Okay, and nowadays actually we can see like computer can generate like more good music. Okay, better than the human. Yeah, even you can generate the training data using GAN. Suppose you are doing a face detection like projects. Okay, and at that point of time, suppose you need thousands of data. Okay, at the time what you can do, you can like use GAN to generate the faces. See, this is completely new faces, this is a realistic image. Okay, you can basically use GAN in many field. Okay, you can use in, like, you can see illegal cases also nowadays. Suppose I think like I think you should be knowing, like in adult film industry, they are also using GANs. Okay, because If you see most of the adults video, they are actually, that kinds of person doesn't exist. Okay, what they're doing, they're generating new character. Based on that, they're making this adult film and all. Okay, so it is also applicable in the adult film industry. Okay, so that's why I told you these kinds of GANs you can use manywhere. Okay, like you can use it to do a good task. You can also use it in illegal field. Okay, it's possible. Okay, now I think you played PUBG, right? PUBG, and there are many games. So inside the games there would be lots of character. This character has been also generated by GANs. Now guys, you are getting what kinds of application can be generated by GANs. See, you don't have to like use it in illegal fields. Okay, because GAN is totally completely a new field. Here actually it's a like very broad field. It's like very interested field. If you want, you can deep dive in the GAN. But I will suggest don't use it in illegal cases, so that, because there are some rules and restriction also, okay, in GANs. I think just before few years, I think there were one system has been I think proposed. I think you know that one, DALI 2. Like, did you heard of DALI 2? It's from OpenAI. So if you just put some text, so it can generate images. Suppose you are writing dog is flying. So what it will do, it will take that prompt and it will generate that images like dog is flying. Okay. See, Delhi, I had the access, but what they did, they, end up my free tier. Okay, I can't show, but I created one video on Delhi in my YouTube channel. So let me give you that one, so that at least you can get some idea how Delhi works. So here I created one video. Actually, I got a free tier access from Delhi. Okay, so just watch this video after the session. Okay, so you will get the idea what is DALI 2. Okay, now see, this is one application. You can generate human faces. Then again, there are many applications. Like suppose you have here, let me show you. You can generate realistic photographs. I already showed you. Then you have you can generate cartoons character. Okay, like cartoon characters or game characters. Okay, you can generate using GANs. Then suppose, see, you can also do image to image translation. Suppose you have input did these images. Okay, so what it will do, it will take that images and related these kinds of images. Okay, it will try to generate also. See, okay, it's similar to these images, but it is doing some modification. Okay, then sketch to image generation is also there. Suppose you are doing some sketch. Okay, and it will able to generate completely realistic images. Okay, so there is one website I can show you, this image to image demo. Okay, see here, edge to cats. Okay, suppose here if I draw something, so let me clear. Suppose let me draw one cat. Okay, my drawing is not good. Let me try. Suppose just consider it's a cat. Okay, now let's convert it to realistic images. Okay, I'm giving you this link. You can also try and show me like how good you are on drawing. See, it's downloading the GAN model. So it's basically S2 cats. Okay, S2 cats model. It is already trained and they have hosted on their, you can say, URL. So you can access and you can test it. Okay, so this kinds of application you will see like everywhere. Okay, so in between, yeah, not only cat, you can also like draw. Suppose you want to generate a buildings, okay, you want to like draw building. Suppose you are an architect, okay, uh, suppose you are a civil engineer. So what you want to generate a new design of a building, okay, it is also possible. See, you can take a window, just draw here, okay, and it will generate completely a new design of building for you. Then not only building, you can generate shoes also, okay, bags also, like there are many. I have given this link. I think you can try. Just open the link, and you can see these kinds of examples are there. Okay, and they have also written like what kinds of data set they have used. So if you see the paper link also, pix to pix paper. Okay, see this is basically pix to pix GAN. Okay, this is the paper. Okay, you can read the paper how they have implemented this one. Even they have also told like which data set they have used. Okay, everything like they have written here. Yes. Yes, 3D model. See, this is the output. Okay, I have just given this sketch. Okay, and it is able to generate these images for me. It is not good because my drawing is not good enough. That's why. But at least you can see it is close to the realistic cat images, right? Someone is telling it's rat. Okay. So guys, you can try it later on. Okay, you can play with this one. Because see, GAN is completely different field, and it's like very interesting. Uh, if you are interested, you can deep dive in. Okay, but today's session, I will give you the idea. What is the actually main concept behind the GAN? Like based on that, if you see there are many GANs. Okay, if I tell you there is a GitHub I got, Ganju. Okay, the Ganju. The name of the GitHub is the Ganju. Someone has created this one. So what he did actually, he collected all the GANs are presented in the world. Okay, he collected in just one place. Even he also gave the paper link. Okay, so till now, what are the GANs has been implemented by the researcher? Every GAN you will find here. Okay, all the names are there, like 3D ED GAN, 3D IW GAN. Okay, then style GAN is also there. Branch GAN is there. There are many GAN. Okay, and all the GAN has a separate task. Okay, so now if you want to if you want to know more about the task, just open the paper, read it out. Okay, what is this GAN specifically? Okay, they're using. Okay, so there are many GANs. Okay, there are thousands of GANs, and it's not possible to learn all the GANs. Okay, based on your task, actually, you will be selecting the GANs model. Okay, which GAN you want to use. Suppose I want to generate human faces. Okay, I want to generate human faces images, so I can use style GAN. Okay, it is already trained. But what is the actual GAN? I mean, concepts. Okay, like how they think. Like, I mean, what is the root algorithm? Okay, inside that, like it is working. I will show you today. Okay, what I will do, I will build one GAN from scratch. Okay, by using Keras, and I will try to generate some of my images. Okay, based on the CIFAR 10 data. I think you know what is CIFAR 10 data. Did you work with CIFAR 10 data before, guys? CIFAR 10, I think you should be familiar with CIFAR 10. I think you have learned in the image classification, I think. CIFAR 10. This data, I think, guys, I think you should be familiar, right? Like aeroplane, bird, cats, dogs, right? So it is the smallest version of CIFAR 100 and CIFAR thousands. So CIFAR 10 means it has 10 classes only. Okay, so these are the 10 classes you have. So what I have why I have selected this data, because it looks like realistic images. Like there are aeroplane, bird, cat, okay, frog, dogs, animals is there. So that is why I will be using. Either you can use also MNIST dataset, but it's a handwritten dataset. Okay, so it's not like that much of interesting. So that's why I've selected this one, because we want to generate something realistic. Suppose I want to generate some animals. Okay, I want to generate some vehicles. So that's why I selected this data. Okay. So basically, you will be learning the GAN actual concepts, like how it is working in the backend. Okay. Based on that theory, all the GAN you can see here, okay, it has been implemented. Okay. but the root like concepts would be same, okay, everywhere. Okay. So now let's discuss about like how GANs work, okay? How GANs work. So before that, let me search about GANs, okay? GANs in Google. Let me see what is GANs. Uh, let's search GANs. What is GANs? So see, here they have written a generative adversarial network is a class of machine learning frameworks designed by, uh, there is a guy called, I think his name is Ian Goodfellow, okay, and his colleagues in 2014, okay, and it has actually two neural networks, okay. This GAN has actually two neural networks, okay. Now let's discuss like how these GANs work, okay. Let me go to my board. So here, sir, how we will get to know that thing created by GANs exist or not? Which one? These images you are talking about, Babia? Okay, see, after, just let me give you this demo, okay. Let's create our own GAN, then I think you will get the idea, okay. Because see, I already told you, if this person is exist also in the world, so it might be a coincidence, okay, but mostly it will create completely new faces, okay. So that is the power of GANs, okay. Even you can't believe, I know, like by seeing the images, I think you can't believe like it is created by GANs, but it is completely created by GANs. So basically what you did, just consider about human, okay, human beings. If I show you thousands of person images, okay, would you be able to imagine someone faces in your mind, okay? Suppose some beautiful girl in your mind. I think it is possible, right? We see dreams, right, guys? Okay, in dreams actually we see lots of persons or lots of things, but that doesn't exist in the world, okay. So this is the concepts actually, so they have mimicked that thing, imagination power. Got it? Okay, so now let's discuss about a little bit of GAN, how GAN works. Okay, so I already told you GANs is nothing but it's a generative algorithm. Okay, algorithm. And in the year of 2014, there was a guy, his name is Ian Goodfellow. Okay. Okay, so there was a person, his name is Ian God, like you can say Goodfellow. So actually, for the first time, he came up with this idea, okay, GANs. So I think we know in the field of computer vision, there are some, I mean, very talented person is there. Like you know, I think you know Jan LeCun, right? Jan LeCun. So we call it we call him actually fathers of computer vision. Okay, Jan LeCun. I think you know him. Then Jeffrey Hinton is there. Jeffrey Hinton. Uh, okay, Jeffrey Hinton is also there. This guy is also there. Okay, so like that actually, Jan Goodfellow he's one of the great researchers, okay, in the field of like GAN, okay, generative adversarial network. So you can also call him like father of GANs, okay. So basically, I don't know like how he like got the idea, the concepts of GAN, but the concepts he has proposed, okay, it was totally amazing. So I think, see, understanding GAN concepts, actually it's very easy, but what I saw, like implementing GAN, okay, it's a little bit tough. Okay, so when after discussing the GAN theory, okay, you will get like it's like very easy, even I can do that, but whenever you will be implementing that thing, okay, it's like very challenging. Okay, so now let's discuss like how you get the idea. Okay, so I already showed you GANs has actually two algorithm. Okay, it use actually two neural networks. Okay, two neural networks. So what are the two neural networks it has? It has the first neural network, it use something called discriminator. Sorry, discriminator. Okay, discriminator. And the second neural network, it use generator. Okay, now I will tell you like what is discriminator and what is generator. Okay, now let's discuss one by one. So first of all, let's discuss with discriminator. Okay, discriminator. Okay, so discriminator is nothing. Actually, we all have worked on this discriminator. Okay, like so far. Okay, as of now, we know about discriminator. So let me tell you. So discriminator suppose it's a neural network. So what it does actually, it takes an input. Okay, suppose it takes an image input, and it's a CNN model only. Okay, it's a CNN model, and in the output it provides, okay, output it provides 1 and 0. Okay, 1 means it's a real image, 0 mean it's a fake image. So basically what you are trying to do, you are trying to do image classification. Okay, suppose I am passing one image as output. Suppose I am passing a dog images here. Okay, dog images, and this neural network is trying to just predict whether this is a real, okay, or a fake image. Suppose, is it really a dog image or it's a like other image? Okay, getting, guys, what is discriminator? It's a simply like CNN model. Okay, like the way you do image classification, dog cat classification, just consider. Okay, suppose you will pass images and it will just check whether this image is real or fake. Okay, that's it. Okay, this is all about your discriminator. I think you already work on this discriminator as of now. Okay, you know this discriminator. Okay, you know this discriminator. Then now let's go to generator. I will check or give two outputs. No, see, you can even give batch of images. Okay, batch of images. Suppose you have given one, suppose 100 of dog images. Okay, you can say 100 of dog or cat images. You just mixed up and you give. Now your model will tell how many of them are dogs and how many of them are cats. Okay, it's just a simply image classification you are doing. That's it. Okay, basically your discriminator. Okay, just consider discriminator is a mentor. Okay, suppose you are learning data science. Okay, suppose just consider you have created a projects. Okay, you have created projects and discriminator is a mentor. Okay, and you are passing your like you are submitting your projects to discriminator. You are telling, is my project is correct or not? Okay, your discriminator suppose know your projects. Okay, it has already experience in that field, so it will check your projects. Okay, if it is everything is fine, okay, it will tell, okay, it's a real. Otherwise it will tell it's a fake. Okay, again you need to rebuild the projects. Okay, so basically you are doing checking. Okay, suppose the input you are passing, whether it's real or fake. Okay, now let's discuss about generator. Okay, generator. So generator is another neural network. Okay, basically it takes noise as input. Okay, noise as input, and it provides you can say generated images. Okay, image. Okay, suppose you are putting some noise. Okay, suppose you are putting some noise data as input, and your generator will try to generate images. Okay, but it can be wrong images also. Okay, it might be random images, but get the concept. Your generator will generate a data means here I am passing as an image. Okay, it will try to give you an image. Okay, it can be random image. Okay, it can be anything, but at least it would be generate something for you. Okay, now let's combine them together. Okay, now how it is working. So basically what we have discriminator. Okay, discriminator. So the output of discriminator is 0 or 1. Okay, that means fake and real. Okay, now you have generator. Okay, so generator takes a noise as input. Okay, and it at least generates something for you. Suppose it has generated one images. Okay, so these images actually will be giving to your discriminator. Your discriminator will take that image. Okay, and it will check whether this image is fake or real. Okay, now how it will verify, okay, whether this image is fake or real. So with that, you will pass another data, something called real data, okay, to your discriminator. Suppose actual dog and cat you are feeding, suppose dog and cat data is there. Okay, and your generator is generating something. Okay, and your discriminator is checking this generated images whether it's a dog or cat data. Okay, basically it's trying to classify whether it's like real or fake. Okay, and it is how it is relating everything, because I'm also providing the real data to my discriminator. So always remember, discriminator will take two input. One is your real data, one is generated data. Okay, number two is generated data. You guys got it? Any questions? Like how two neural networks are combined? Okay, so basically what is happening? Okay, what is happening? So just think like whenever this young good fellow, okay, suppose there was a, like you can say problem statement was there. Can we generate a data? Okay, can we generate a data or not? Suppose if I feed 1000 cat images, okay, if I give 1000 cat images, so if I can able to generate a completely new cat or not. Okay, this was the idea. Okay, now this young good fellow like thought, okay, I can do that. Okay, how? I can use two neural network. One is like discriminator and one is like generator. By using discriminator, I will check whether the data I'm getting, okay, from my generator, okay, is it fake or real? Okay, how it will evaluate? Because I am also providing the real data. Okay, it will check whether, suppose this is just a classification model. Okay, basically what you are passing suppose dog images, real dog images, okay, and fake dog images. Okay, basically it is trying to do classification. Okay, trying to do classification whether this generated images is real or fake. Okay, if it is fake, it will go here, it will back propagate here. Okay, back propagation. Okay, I think you know back propagation. It will update the weight in the generator neural network. Okay, then again it will learn something, right? Again it will generate something, give it to your discriminator. Your discriminator will check whether this generated image is real or fake. Okay, if it is again fail, again it will come here, it will do the back propagation. Okay, again it will generate something. Suppose you have run 1000 epochs. Okay, 1000 epochs you have run. So at the end, what will happen? It would be able to generate the dog images correctly, right, guys? As per the neural network theory. So far, you know. Is it make sense, guys? Just let me know whether it would be generate dog images or not. If I do multiple iteration like that. Just write yes or no. Okay. So basically what is happening? Now it is able to generate dog images. Now it will go to discriminator. Your discriminator will relate. Okay. It's a dog images. Now it will give real. Okay. It's real. Now it on doing the back propagation. Okay. Now your loss is close to 0. Okay. Loss is close to 0. That means you have trained your generator. Now what you will do, you will take the generator. Okay, it will separate out the generator and you will take it as a model. Okay, and that would be your prediction model. So now what you can do, you can give any images, any noise, okay, any noise to this model. It would be able to completely generate a new dog images for you. Okay, this was the completely GAN idea. Now just see how beautifully he thought the entire idea. Okay. Guys, any questions? Any, like, did you clear with the concepts? How generator and discriminator are working? Just write yes or no. See, discriminator is just a CNN network. Okay, it's just a CNN network you have learned. Okay, the convolutional layer, max pooling layer, that's it. Okay, but this generator model will be a little bit different. I will show you what is inside that. No, it's not a VGG16. They have created a different architecture. Okay, I will show you whenever I will go to the code part. Okay, but just consider the convolutional layer, leaky ReLU you have learned, all the thing we'll be using. Okay, using that only we'll be creating the discriminator. It's just a classification algorithm. Okay, classification neural network. That's it. It takes two input. One is your generated images, one is your real images. Okay, and it will check whether this generated images is real or fake. If it is real, okay, that means it don't do anything. If it is fake, it will upgrade the weights to your generator so that your generator can generate real images. Okay, close to real images, something. Okay, by the noise itself. Noise is what? Suppose you are giving some colors. Suppose if you are a painter, okay, what I will give you pencil, suppose. Okay, pencil, brush, some colors. Okay, using that, this is your materials actually, right? This is your materials. Okay, using that you would be able to draw beautiful drawing for me, right, guys? Just relate with human being. Okay, now I think you got it. So the noise you are passing, it's just nothing but, suppose you are a painter. Okay, I'm giving you pencil, colors, brush, and everything as a material. Using that material, you are generating something. Okay, and that this generated thing you are giving to your mentor. Suppose you can call it guru. Okay, you are passing to your guru and telling him whether this generated thing is correct or not. Okay, then he's responding. Okay, it's not correct or it's correct. Okay, if it is not correct, again he's telling to you, again you are improving to your drawings. Okay, again you are feeding to your discriminator. That's how actually this loop is going on. unless and until you are not able to generate these images completely realistic. Okay, I think this is the easiest explain I can give, guys. I think it should be clear now. Just tell me. Yes. Okay. See, this idea is like very simple. Okay, the GAN idea is very simple. Two networks we use, generator, discriminator. Your discriminator checks whether generated input is correct or not. If it is not correct, go to generator, upgrade the weight. Okay, again it will try to generate something by taking the noise. Okay, again it is fed to the discriminator. This loop will be keep on going unless and until your generator is not able to generate something realistic. Okay. Yes, it's simply CNN backpropagation. Okay, not nothing. I mean, nothing new here. Okay, Babia. Yes. How many like of you got the whole concepts of this GAN? Okay, these two neural networks concepts like discriminator, generator. Any confusion you can ask me, because uh, I will be discussing something new. Okay, because this thing is like very basic. I think you should be understand with that. Just tell me if you have understood. Just write yes, and or I need to explain it again. Yes. Yes, we first train the discriminator. Okay, I will show you because, but see, I can't say like we first train the discriminator. This training would be happening together. This two network will be keep on training together. Okay. Because see, your discriminator suppose know everything. Okay. Suppose it knows everything. 100% it knows everything. So what will happen? The data you will give every time. It will tell, okay, it's a fake. It's a fake. Okay. But suppose just consider as a like human being. Suppose when a child born, okay, the child, the more actually he will be able to learn if we just give more childs. Okay, like besides him. Okay, suppose you can learn something. Okay, you can learn a lot from your ages only. Okay, if you just try to learn from some other ages, suppose from some older person, okay, you won't be getting interested, right? So similar thing actually. So if this training is happening together, that means it would be do this job, okay, like in a very good way. Okay, so yeah, simultaneously training you can talk about, but slightly I can talk about your discriminator will be training first of all. Okay, because see, your discriminator will know, suppose suppose it for the first iteration it will know, suppose 5%. Okay, 5% it will get something knowledge. Okay, then see, if it, I mean, is there is no knowledge. Okay, so what will happen? It won't be able to detect whether this generated image is fake or not. Okay, okay, that's why at least we need some knowledge here. Okay, after building the knowledge, it will generate something. It will tell whether it's like you can say fake or real. So it has now 5% idea on that. Okay, now it would be able to say, yeah, it's a fake. Then what it will do, it will send the response here to the generator. Hey, just upgrade your weights. Okay, the image you have generated, it's not correct. Then what it will do, it will also upgrade. Okay, it will also train. That's actually, it would be training simultaneously, but your discriminator will learn first, then your generator will learn. Got it? Ashok Kumar. Okay. See, this concept is like very interesting. But implementation wise, like it's like a little bit complex. Okay. But just try to understand the concepts. Okay. Like how beautifully you thought the idea. Okay. Using this concept, actually, now you're able to generate that kinds of realistic images. Okay. But for that, you need, okay, like you can say lakhs of trainings. Okay, lakhs of trainings, and you need good computational machine. Okay, See, random data, we can generate noise using NumPy. Okay. It's just an array. Image is what? Like, it's just a pixel. Okay. Pixel is what? It's just an array. We'll define some random value. Okay. And we have our real data. Real data means, suppose what? I have 1K dog images. This is my real data. Random data I can generate. Okay. But random data, how I'll be generating? I will be generating using my generator. Okay. And generator will take a noise. Noise is what? I will give some random value. Okay. Random value. Okay. As a flat and random value, I will give, suppose 1, 2, 3, 4, 5, 6, 7, 8, random. We'll take that. Okay. It will generate something. Okay. That's how actually it would be able to get the relationship, like how image is consist. Okay. It will automatically learn by doing the back propagation. Beginner C, a discriminator will predict whether your generated images is fake or real. Okay. How it will get to know whether, because see, it would be trained on what? It would be trained on real image also, fake image also. Okay. Suppose you are doing a loop. In the first loop, first of all, it will take, suppose 64 real images, 64 generated images. That means fake images, because initially it would be fake. Everything it will be generated, it is a fake images, right? It will train. Okay. It will train itself. Okay. It will train itself. Then whenever you are passing that one, that means your image, okay, then it will able to like detect, because see, when it would be like very difficult to your discriminator to differentiate two images. Okay. Whenever it is close to, suppose you also generated one images as a dog, and it is also trained on the dog. Okay. These are close, very close. At that time, it will be a little bit confused. Okay. But initially, it will generate a random image. Okay. Random, that means noise images only. It will easily able to differentiate, right? Because this two data is from different distribution. Okay. Yeah, generator will generate something. It can be fake, it can be real. I can't say when it will generate fake and when it will like generate real. Okay. But whenever you will doing the multiple iteration, there would be a time it would be able to generate completely, like you can say, real data. Okay. I will show you like how it will get to know. Okay. I will show you. Now just tell me, did you get the concept or not? Okay. Okay. Now let's work on this discriminator part first of all. Okay. Because we already know this discriminator. Like we have already worked on. Okay. Now let me open my code. So what I will do, I will create one collab notebook here. Change runtime to GPU. Let's connect. Okay. So I already have written this code. So what I will do, I will just copy paste from here because it's like very lengthy code. Otherwise it will take a lot of time. Okay. I will explain the code like what I have written. Okay. So first of all, let's take our CIFAR 10 images. Okay. Let's take our CIFAR 10 images. So here what I'm doing, I think you know, CIFAR 10 is already available in Keras. You can call from Keras dataset CIFAR 10 import load data. Okay. And I'm using matplotlib to do the visualization, okay, of my data. So here basically I am loading my data, okay, using load data. So what it will return? It will return my xtrain, ytrain, xtest, ytest. Okay. Then what I'm doing, I'm defining a for loop. Inside for loop, I'm creating one subplots. Okay. Like around 42 images I want to plot together. So I'm taking 42, you can say subplots. Okay. In that subplots, I'm like you can say rendering my image one by one. Okay, now let's execute this code. You will get the idea. Okay, now see, it is nothing but I'm just loading my data. Okay, because I need my real data. I already showed you. Your discriminator need what? It needs real data. Okay, and it needs fake data. Okay, so I need real data. So as a real data, what I'm using Shepherd 10. Okay, either you can use person data, you can use Dopcat data. It's up to you. Okay, but it is already available in Keras. That's why I'm implementing this. I'm taking this one. Okay, so I will feed that data to my GAN model, and my GAN model will try to generate something new from these images. Okay, so that is the concept here. So this was all about loading data. Now let's import some of the packages for the discriminator I'm going to implement. So here, I think you all know, these are the things: sequential layer, dense layer, conv2 layer, flatten layer, dropout layer, leaky relu. Okay, so guys, you know, these are the thing I think it should be familiar with if you have already worked on CNN. Okay, so here, instead of relu, why I'm importing relu? Okay, so as per the research, actually they have shown in the GANs architecture, okay, if you're taking leaky relu, it will give good accuracy. Okay, it is proven by research. So that is why don't take relu, because I think you know about relu and leaky relu. There are some slight changes are there. So relu is nothing but, okay, it will look like that. Okay, suppose it will look like that. This is a relu, but in leaky relu, what is there? So it has some, suppose see, if your value is like -1, okay, -1, it will consider as 0, but here you have some value here, okay, in leaky relu. So I think you know, you are familiar with this curve and all. Okay, so that is why actually research has proven using leaky relu in GANs, okay, you will get good accuracy. Okay, and plot model from Keras I'm importing because the architecture I am going to implement, okay, I can also plot as the images. Okay, I can also visualize that architecture. Okay, so that is why. Now let's import. Now let's define our discriminator architecture first of all. So now just carefully see the architecture. Anything new you can see here, guys? Just tell me. If you have learned CNN, I think everything should be neat and clear. Just tell me. Anything new you can see here or not? It's just an image classification model, guys. Just see. Right? Okay. So what you are doing, you are defining your discriminator model. Input shape, I am providing 32 by 32, 3. Can anybody tell me why I'm passing 32 by 32 by 3? Anyone? Any idea? As the image shape input. Just see the data. I think if you have worked on CFR 10, so I think you know the resolution of the data, right? Let me show the resolution. So let's call my xtrain. If I show you the shape of the xtrain, okay, what it will return? It will return you have 50,000 images there, and the resolution of the image is 32 by 3 because it's a color images. That's why the channel is 3. Clear, guys? That's why I'm taking 32 by 3. But if you are applying on some other data at that time, you should be familiar with your input shape. Okay. Why leaky relu? Leaky relu, because research has proven, okay, whenever they did research on GAN, they created different architecture with different activation function. And what they observed, leaky relu is working fine, okay, in the GAN architecture. That is why I've taken leaky relu. Okay, got it? If you just read the paper of GAN, okay, you will get it. Okay, see what you are doing. First of all, you are taking one convolutional layer. Okay, you are taking the kernel 3 by 3. You are keeping padding is equal to same. Okay, then input is equal to your input shape. Okay, then you are applying some stride. Okay, why you are applying stride? Anybody tell me? What is the use of the strides? What you want to do exactly applying strides? You want to downsample your image, right? No, downsample your image, right? Okay, but you can also ask me why I didn't use max pooling here. Okay, it is also proven that if you are using stride instead of max pooling, okay, you will be getting good accuracy. Okay, that's why you don't, because see, max pooling also doing the downsampling for you. Stride is also doing the same thing, but research has proven if you're taking stride instead of max pooling, you will be getting good accuracy. Okay, so this is all about your convolutional layer. At the last, you are taking one flattened layer, you are taking one dropout layer. Okay, because you don't want to like your model to be overfitted. And at the last, you are taking dense and one neuron. Why you are taking one? Can anybody tell at the last layer why you are taking one and why you are taking sigmoid? It is very, I think, yes, binary classification. Okay, because your discriminator, what it will tell whether this generated images is fake or real. That thing, that's it. Okay, now let's test this one. Okay, now let's test this I mean discriminator we have defined. So first of all, what I will do, I will show the model summary to you. So here I'm calling my function define discriminator. Okay, and I'm printing my model summary, and using plot model, the model summary I'm getting, I'm trying to save it as a PNG format. Okay, PNG images. So now let's run it. I think you will get the idea. So here, if you see, it will save one PNG for you. This PNG is nothing but it's your model architecture only. Okay, you can also save it as image from. Okay, by looking into the image, you will get your entire model architecture. Bhavya, what you were asking? It's just a image classification code, guys. Just see. Okay, you want to do binary classification. Because I already discussed, your GAN has two neural networks. One is discriminator, one is generator. Discriminator is just nothing but it's just a classification neural network. Okay, and generator is nothing but it's a generative, like you can say, neural network. It will generate something, and it will do the classify whether this generated image is correct or not. Okay, guys, just try to understand. Don't go to depth, otherwise you will get confused. Okay. Okay, now see, this is your model architecture. I think you should be familiar with this one. So basically here you are applying what are the layers. Okay, it will show the summary, okay, to you. And you can also see as a image format, so that it is like very it will be very easy for you to understand like how your model looks like and all. Okay, that's it. Now what I'm gonna do, I'm going to generate some real samples. Okay, real samples means real data. Okay, now let's generate load. First of all, let's load our real data. So this is the function. So what it will load, actually it will load my real sample. Okay, so real sample is what I imported. I think you remember this one, load data, right? Load data, my shifter 10. So this is my real sample. Okay, and I don't want the Y and test data. I only need my X train. Okay, that means my image only. Okay, and what I'm doing, I'm converting to float 32, and I'm applying the scaling operation. Okay, I think this is a basic pre-processing. Okay, you are applying on your images. That's it. Okay, why scaling is required? Okay, because I think you know there would be some pixels, and pixels value may differ from 0 to 255. Okay, to bring them to -1 to 1, okay, yeah, you need to scale it down. Okay, so that is why scaling is required. And research has also proven if you are applying scaling, so that your whenever it will be doing the back propagation, okay, at that time it would be a little bit faster conversion. Okay, so that is why. Okay, so this is all about our load samples. Okay, now let's load our samples. Let's call this function. So I'll call this function and let's run it. So now you will see it will return 50,000, 50,000, 32 by 3. Okay, but if I show you the data, it has been scaled down. Okay, all the data has been scaled down. If you see, it has been -1 to +1. Okay, the range. But at the first, okay, if I show you the xtrain, so here let me show you. So it had some other value. See, guys. Okay, that's why I applied the scaling operation. So this was all about. Okay, now I want to generate some real samples. Okay, because see, I can't pass all the 50,000 data together in my model. Okay, I can load because I have very less memory. Okay, so for what is the solution you have? You have to pass the data as a, you can say, batch. Okay, I think you know, like batch training, guys. Like batch size you mentioned, like 128, 64, right? So that is why I'll be defining another function. So this function will take two things. One is your entire data. One is your entire data set. And one is like your number of samples you want. Okay. So what I'm doing here, basically, I'm calling NP. Okay. That means from NumPy, there is a random is there. So what it will do, it will like randomly selected some of the data from my entire data. Okay. Like how many data I want, the n number of samples I want, and it will return me. Okay. And with that, it will return the labels as 1. Okay. Why it will return labels as 1? Because here I'm not considering it's a dog, cat, or I mean, you can say, if you see the image, okay, it's a horse, it's a cat, it's an aeroplane. Okay. I don't want this label name. I only want this image is real or fake. Now, if I ask you this image is real or fake, what you will tell? Is it real or fake? Guys? Real, right? So as real, what I mentioned as 1. I think you remember here. Okay, real as 1, fake as 0. Clear? So that is why I'm making the label. Okay, the X data I'm getting, with respect to that, all the Y I'm making as 1, because I am considering all the generated real samples I'm getting, it is true. That means it is real data. Clear, guys? Just write yes or no. Okay, so now let's run it. So now let's test this function. Okay, so what I will do, I will call this function generate real samples, and I'm passing my entire data set. That means X I'm getting. Suppose this is my load real samples, right? It is giving me 50,000 example. Okay, this 50,000 example I'm passing here. From this 50,000 example, I only want 164, okay, number of images I'm passing to my function. So what it will return? It will return to me two things to me. One is like my X data, one is my Y data. X data is nothing but it's my image array. Y is nothing but 1. Okay, that means this is my real images. Okay, now let's print it. Okay, see the shape is also same. 64 batch I'm getting. The image size is 32, 3, and the label also I'm getting 64, and the dimension is 1 because it's just a Y. Okay, it's just a label. Okay, let me show you. If I print Y, it will give you 1. Okay, that's it. Now, by seeing this image, now you can see this part is completed. This real part and define discriminator is completed. Now, what is left? Can anybody tell? What I need to create for the discriminator? No. Just consider as an input and output. Okay, your discriminator will take what? It will take two input. One is like your real data, one is like your fake data. Okay. So I completed my architecture of discriminator. I completed my real data loader. Now what I need to do, I need to generate fake images, right? So let's define that function also. Because first of all, I won't be taking from my generator. Okay. First of all, I want to show, okay, I want to show how your discriminator is working. Okay. Okay. That's why I will be generating using NumPy, this fake data. Okay. So that is the motto. Now let's generate some fake samples. So this is the function to generate the fake samples. Now see how I'm generating the fake samples. I am calling from NumPy this random. Okay. Randit. I am defining the shape I want. Okay. Number of samples I want the data. Okay. So it will generate the random array for me. And I'm defining as 0. Okay. Why I'm defining as 0? Guys, tell me. Because this is my fake samples, right? Guys, get it? Like how I'm generating the fake samples. Okay. Now let's run it. So again, let's test this generate fake samples one. Okay. So I'm calling that one and I'm telling I need 64 example. Okay. Now you can see this array size is same or not. Okay. Both are same because I'm defining the shape like that only. But the array I'm getting, it is totally random array. Okay. Completely random array I'm getting. Okay. Because I'm using random function here. Okay. Now this is your fake images. Okay. Yes, real label I kept one. See why? np.once. Okay, I'm keeping. And for fake, I'm defining as 0. Clear? Advik. Okay. Now let's plot our fake images. Now let's see how it is look like. So far I already showed you how your real images look like. I think you got it. Here I'm printing. Now let's print your fake images. Okay. So what I'm doing, I'm calling pyplot. I am show, and the generate fakes data I'm getting. Okay, X. I'm taking the first array of it. Okay, first example of it, and I'm trying to plot it. Now let's see how it looks like. See? Okay. Now I think you got it. What is fake image here? So it has some pixels only, random pixels. Okay. Okay. Now tell me, if you have a real dog images here, let me write it. Suppose you have real dog here. Let me draw a dog. Let's don't draw it. Let's consider there is a dog you have. Okay. Otherwise, let me do one thing. I will take a snapshot. Go to my okay. Now let's paste it here. Now tell me, it would be hard for your classifier to classify whether it's a fake or it's a real. Now tell me, it would be easy or hard? Just see these two images and just, okay, it would be easy because this distribution and this distribution is like completely from, like it's not matching. Okay, it's completely different. Okay, that's how your discriminator will, like you can say, get to know very easily, and it will take very less time to give you 100% accuracy to classify this is as a fake, this is as a real. Okay. But suppose there is a position, okay, whenever let me, yeah, okay, suppose there is a position, copy. So whenever you will be doing multiple training of your generator, suppose your generator will generate some images, okay, and it would be close to the dog. At that time, now tell me, it would be easy or hard for your discriminator to classify whether these two objects are different or not? Hard, right? Okay. Now at that time, if you see the loss, okay, it will also give you 1. It will also give you 1. If you see it would be close to 0, that means your generator is able to generate something realistic images, okay? At that time, you can get to know, okay, your generator has been trained. It has adjusted its weight, okay? Okay, so that is the concept, guys, okay? Now let's move further. How it's making the dog images from noise? It's doing some multiple iteration. It's getting the relationship, guys. So now you will be more clear. Let me show this example code. Okay, let's open this one here. Okay, now see, this is my fake image look like. Okay, now what I will do, I will train my discriminator, okay, by using my fake images and real images. So this is the function for that. Okay, now see, this is one train discriminator function I have written. What it will take the discriminator model. It will take the data set, okay, like your entire data set. It will take the number of iteration, so it is already defined, and the number of batches 128. Okay, now here what will happen, here I am taking batch sizes 128. Okay, so here what I will do, I will take 64 real image and 64 fake image. Okay, then I will train my model. Okay, so my model is not imbalanced. Okay, my model is not imbalanced, data is not imbalanced, because I'm taking 64 as real, 64 as fake. Okay, then I'm training my discriminator. Okay, that's how my discriminator is learning whether this is a real or fake image. Okay, easily it would be able to learn, because I showed you here, it would be easily able to classify because this true distribution is not matching. Okay, so here that same thing I'm doing. I'm first of all, I'm dividing this batch size by 2, because it is 128. If you divide by 2, you will get 64 half batch. Okay, then you are defining for loop, you are giving the number of iteration, like 20 iteration I want to train. Okay, now first time what I'm generating real samples. So generate real samples, I think I created the function already. See, it will take my entire data set and it will provide the number of batch I want. So how many batch I want? I want 64 images, because I have passed 128 as my batch size. Whenever I'm dividing by 2, it's becoming half. So that is why I'm taking 64 as my real image, and I'm doing the training. See, this is my model, and train on batch. Okay, so this is one concept in Keras. So basically what we do, actually, we take the data. Okay, we take the data, suppose dog, suppose fake or real data. Okay, real data, and we do random shuffling. Okay, guys, I think you familiar random shuffling. Okay, you just mix them together and then you feed the data to your model, right? But research has proven here you don't have to mix the data. Okay, so first of all, what you need to do, you need to train on batch. Okay, so there is another function. What we do, right? Actually, model.fit we write usually, but here you don't write. You don't have to write model.fit. Instead of that, you need to write model.train on batch. Okay, so first of all, it will train on real data. Okay, then again it will train on fake data. Okay, now I'm generating my fake data. I'm getting my x fake, y fake. Again, I'm calling my model train on batch. I'm passing my fake data. So basically what is happening, first of all, it is getting trained on real data, then again it is getting trained on fake data. Okay, the number of real data you are getting, it is also same. The number of fake data you are getting, it is also same. 64, 64. Is it clear, guys, what I am doing here? Okay, now let's run it. Now you'll see, let's call my function, because it's, I have just defined the function. Now we'll see very easily, okay, and in a very short time it will be able to give me 100% accuracy for the fake, for the real image also. See, I'm printing the accuracy score. Okay, now I'm calling my discriminator model, I'm loading my data, then I'm calling this train discriminator model. Okay, and inside that I'm passing, because it will take two things, model and data set, and these two parameter I have already provided. Okay, that's why I'm not giving. Now let's do the training. Now see, guys, iteration 1, real accuracy was 38%, fake accuracy was 3%. Iteration 2, real accuracy was 92%, fake accuracy 70%, 17%. Okay, then with that, actually, if you see, real accuracy is 97, fake accuracy is 100%, close to 100%, 100%. Got it, guys? What is the intuition I have given here? Is it matching or not? It is easily classifying these two images, fake or real. Got it? Is the discriminator network? Train on batch, it will see, first of all, what you do actually. In actual training, you take both the data, both like separate clips together, and you do the shuffling, okay, random shuffling, you mix them together, then you call model.feed, then you feed your data. But here, I'm not doing like that. First of all, I'm generating my real samples. Train on batch means you only want to train the real sample to your model. That's why I'm calling train on batch. I'm passing my real data. Once it is done, again, I'm generating fake data. I'm calling my model. Again, I'm calling train on batch. It will train the fake data. So basically what is happening, 2 times your model is getting upgraded. Okay, your weight is getting upgraded. The first time it is getting upgraded during real sample. The second time it is upgraded during fake samples. Okay. Mahima and Babe, I think you got it now. See, loss function I have defined, if you see here. Optimizer wise, I'm using Adam, loss function binary cross entropy. We don't combine like real and fake. We don't combine, because research has proven instead of combining them together, we need to train on batch. Okay, separate. Okay, this is their research, I mean the work. They told us to do like that. That's what we are doing. No. See, discriminator will not be involved in prediction. It is only for the training. Okay. Once training is done, I will take my generator model. I don't need my discriminator model, because I want to generate something. I don't want to predict something here. Okay. Only prediction is required. Whenever my generator is generating something, I want to verify whether this generated image is fake or real. Okay. It is matching the correlation with, see, those were telling like how it is, why we are providing real data, because if I am not providing the real data, how will it will get to know, okay, the relation. Okay, it is generating the data. It suppose see the dog it is generating, it can be different, it doesn't exist. Okay, this dog, it is completely new, but the relation of the data, it would be similar, the correlation would be similar, right? With your real data. At that time it is getting to know, okay, I'm close to, okay, very close to. Suppose there are many dogs, but those are dogs only. Okay, they have two eyes, 2 ears. Okay, but it can be different, the color might be different, but the data, you can say distribution, it would be close, very close. Okay, that's how actually it would be able to figure out like I have generated something here. See, I think multi-class, yeah, multi-class also. Suppose what it is doing, here I am providing multi-class data, right? Here I have 10 classes. So what it is doing here, first of all, suppose I'm providing all my 10 classes here. Okay, so from the 10 classes, it can generate anything. Suppose it can generate animals, it can generate aeroplane. Okay, with that, it will try to see the correlation, whether it is close to that or not. Okay, that's how it will be generating. Okay, so now this was all my discriminator. Okay, discriminator, like it is training like very easily because it can separate out the data. Now let's work on the generator part, because discriminator, I think I have already explained, it will take to input real data, fake data, generated data. But generated data, I'm not taking from my generator, I'm making my own fake samples. Okay, because I only wanted to show whether this function is working or not perfectly. Okay, later on I will combine this discriminator and generator model together, and I will make a composite model, and I will show you, okay, how to take generated images from generator and I will pass. Okay, instead of this sample, fake sample, okay, I will take the data from my model itself. Okay, then I will give it to my discriminator. Okay, now let's work on generator part. So let's import something. So here, I think you will see some of the changes, little bit changes. Now just tell me, what are the new things you can see here, guys, in the generator part? I think this thing, it is new, convolutional 2D transpose. No, latent dimension is just input. Okay, so it is opposite of your convolution. Okay, so in convolution, what happens actually? Let me show you. Convolution, actually, you try to do the downsampling, right? Downsampling. Suppose you have 10 cross 10 images. Okay, 10 cross 10 images. If you do convolution, okay, what you will get? You will get suppose 5 cross 5. Okay, suppose you do downsampling here, right? Downsampling, but conv 2D. Let me take my pen. Conv 2D transpose. I think you know already transpose. Transpose is like, opposite. Okay, opposite of it. Suppose you have 2 cross 2 image. Okay, if you apply this con 2D, okay, it will give you 4 cross 4. Again, if you have 4 cross 4, if you again apply con 2D, it will give you 8 cross 8. Okay, it will make 2 times, okay, larger. Okay, got it, guys? What is con 2D and what is con 2D transpose? Basically, it is opposite of con 2D. In con 2D, you do downsampling, yeah, and in con 2D transpose, you are doing upsampling. That means you are increasing the dimension of your image. Got it? Yes, you are basically making the dimension up. Suppose you just pass 2 cross 2 images. After applying this con 2D transpose, your image will become 4 cross 4. Again, if you apply, it will become 8 cross 8. Again, it will apply, it will become 16 cross 16, 32 cross 32. Getting? Okay. Now tell me why I want to do the transpose operation. Okay, because just see the generator here carefully. So your generator, let me give a little bit idea of your generator so that it would be clear. So suppose what will happen actually. This is your generator. Okay, this is your generator. So your generator will take what? It will take noise as input. Noise. And it will provide what? It will generate some images. Okay. And what should be the dimension of the images? Can anybody tell? As per the real images I passed here. No, augmentation is not here. 32 cross 32, 3. Right, guys? Okay. But noise, noise is what? Noise is just an array. Suppose I am passing 2, 3, 4, 5, 6, 7, 0.9. Okay, it's my noise. Now this is a single dimension, like 1D array. Okay. Now, if I want to convert this 1D array to 32, 32, 3, okay, I need to upsample this one, right? So that's why I'm using conv 2D transpose. So what will happen basically, suppose if you pass 2 cross 2 image, okay, if I apply this conv 2D transpose, it will make 4 cross 4. Again, if I apply, it will make 8 cross 8. Again, if I apply, it will make 16 cross 16. Again, if I apply, it will become 32, 32. Okay, I need to apply 1, 2, 3, 4, 5 times. Okay, then I will get this dimension. And this is my generated images from my generator. Okay, guys, got it? Now, why I'm using conv2 transpose? I think it is clear. Just write yes or no. Okay. It would be more clear when I will show the example. Okay, so basically see what I am doing. Latent dimension is what? Latent dimension is an array. Okay, I'm taking just one array. So latent dimension wise, what I'm taking. Yeah, so suppose this is my, let me again write here. This is my generator. It will take noise. So noise, we would have some dimension, right? So let's consider 100 dimension. Okay, 100 dimension data from a Gaussian distribution. Okay. Why Gaussian distribution? Because researcher has proven you need to take this noise from a Gaussian distribution. It should be Gaussian distribution. Okay. And this data you need to pass to your generator. You need to apply something called conv to the transpose. Okay, transpose, so that it can be upsample your data to 32 by 3. Okay, so this is the entire idea. Now if you see here, first of all, I'm taking the latent dimension. First of all, let's define this one. Okay, then I think you will get it. Now see, latent dimension I'm passing as 100. Okay, because I'm taking just 100 you can say 100. Latent dimension is what? Suppose there is an array. Okay, there is an array, and in that array there is 100 value. Okay, 100 value. Okay, so now what will happen? Inside that I'm defining one nodes. Okay, nodes means here first of all I'm initializing my image as 4 cross 4, and this is the depth of my images. First of all, I'm taking 256 depth. Guys, is it clear? Like 4 cross 4. Then if you apply cont 2D transpose on 4 cross 4, what it will return? It will return 8 cross 8, right? Then again, if you apply on top of 8 cross 8, okay, you will get 16 cross 16. If you apply again 2D transpose on 16 cross 16, what you will get? You will get 32, 32, right? And this is my requirement. And at the last, I'm taking con 2D just 3. Why? Because I want my channel to be 3, right? 32, 32, 3. Is it make sense, guys? Just let me know. I am starting my image dimension from 4, 4. Okay. I'm taking the depth initially 200, 256. No, it's just batch size. Okay, 120 is a batch size. Input size is 100 value. Okay, like this, suppose this is an array. Okay, this is one array. Inside that you have 100 value like that. Okay, this is the latent dimension you can consider. Later on, what I'm doing, I'm converting to the nodes. Okay, like I'm initializing this array, I'm converting to 4 cross 4. Okay, then I'm giving a depth here. Okay, this is the noise, guys. Actually, this is the noise you can call. Suppose random array I'm passing, that array I'm converting to the image shape. Okay, and the image shape, first of all, I'm taking as 4 cross 4. Then after applying conv to the transpose, I'm making it 8 cross 8, 16 cross 60, 32 cross 32, and this is my requirement. At the last conv layer, I'm taking three output because my depth should be 3 because it's a RGB images, right? At the end, you want to generate some RGB images. And what is the channel of RGB images? It's 3. Okay, making sense, guys? Okay. And how it is doubling the value? Here you are applying the stride, see? So during convolution, if you apply stride, what will happen? It will downsample your value, okay, as half. Like first of all, it was what? If you see here, first, suppose if you take 64, okay, if you apply stride, okay, it would be half like that. But here you are doing opposite of it, so that's why it would be double. Okay, 8 cross 8. If you again apply 2, 2 stride, it will be become 16 cross 16. One 128 is a batch size. Okay, I will show you. Just wait. Now let's define the architecture of my model. Let's print it. Now see, this is my model architecture. Okay, the same I think you saw. Now let's define our latent points. Now you guys have questions on latent points. Now let me show you the latent points here. Okay, now generate latent points. So latent dimension. What is the latent dimension? 100. Okay, latent sample. How many samples you need, guys? It is 64, right? Because my batch size was 128. Okay. Now see, np.random randint. Okay. Now this will give you your, let me print it. Now just tell me this latent dimension is clear or not. Okay. It will give me 64 array with the shape of, with the value of 100. Is it clear now? Each array will contain 100 value. And I don't want just one image. I want 64 images. 64, you can say noise, because I need to pass 64 as real input, 64 as noise input. Okay. So that's why I'm generating 64 noise, and each noise containing 100 example. Got it? Okay. Now let's generate fake image. So this is the function of generating fake image. Now I will be generating fake image by using my generator model. Now how I'm doing, I'm defining one function. This function will take Not see, just what you are doing, you are calling np.random randint. Okay, you are giving latent dimension 100. Okay, and number of samples you want 64. Okay, so it will generate array. Okay, 64 rows and 100 column it will generate. Okay, and it will give you the input. Then again you are doing the reshaping. Okay, you want number of sample to like previous, like 64, and latent dimension at the last. Okay, that is why you are doing the reshaping, and this is the output. Yes, 64 images with not 100 dimension. Each array will contain 100 value. Let me show the first array, data.first array. Now if you see the shape, it's there are 100 value in that array. Okay, and how many example I have 64 example. Just try to understand, it's just a basic array. Got it? This is your noise. Actually, this is your noise. Just pick the first one and try to see. First example, this is your noise. Okay, this noise I will pass to my model, latent dimension. Okay, and it will, you can say, do this upsampling to me. It will convert to 32 32 3, automatically convert. Yes, image array for one image. Okay, this is just for one image. Okay, and that's how many images I have 64 images, because I told you I will pass 64 100 I mean real image, 64 fake image. Fake image is what? My noise, because I told you your generator will take noise as an input. Vignesh, I think it should be clear now. Okay, now this is the generate fake image. Okay, now what I'm doing, I'm passing my generator model, latent dimension, number of samples. Okay, now generate latent points. Okay, latent points, this is the function I have created. It will give you the latent points, right? 64. Okay, now this 64 you will pass to your model, like generator model you have defined here. This is the generator model. Well, first of all, this model will have some random weights. Okay, because we haven't trained this generator. Okay, it is totally fresh model. Okay, so then I'm trying to do the prediction. So will it be able to predict correctly, guys? Tell me. It will give me some random value and all, right, as output. And what would be the output? 32 32 3. This image it will return, and y is equal to 0. Why I'm doing? Because this image is not real. This is a fake images. Okay, clear, guys? Now see, previously I was creating the fake data from NumPy. Here, generate real samples, generate fake samples from NumPy. But here I'm not doing that. I'm generating from my generator model. I'm trying to do the prediction. So if you do the prediction, what it will return? It will return this thing, 32 32 3. Okay, this is my image. This is my generated image. This generated image I will pass to my discriminator. Discriminator will check whether this image is correct or not. If it is not correct, it will come here, do the back propagation. It will upgrade its weights. Okay, again it will do some prediction. Okay, again it will pass to my discriminator. Again it will check. Like that it will work. Okay, now let me show you what kinds of images it has been generated. Okay, by my discriminator model. Now latent dimension I am passing 100. I'm defining my generator model. I'm passing my latent dimension here. Okay, now number of samples I want as my output. Okay, from my model, it's 40. So generate fake image. Okay, so model. So here this function I'm calling, I'm passing my generator model latent dimension, because it will take, these are the input. Okay, I'm passing my n samples. Okay, now again what I'm doing, it will, what it will give me, it will give me my images. This model will predict my images. It will generate some images. That images I'm doing scaling, because I want to do the visualization. And this image I'm trying to visualize. Okay, this is the code, the same code I wrote at the top. I think you remember this code. Okay, I'm defining subplots. In the subplots I'm trying to show the images. Now let's run it. Now see, this is empty, totally empty, because it has been generated anything, because my generator model, it's completely new. Okay, I haven't trained the model. Okay, instead of training, I'm trying to do the prediction. That's why there is nothing. But if you zoom something, you will see some of the pixel here. Okay, guys, is it clear? Okay. Now, guys, let's take 5 minutes of break. Okay. Now let's start with the like our defining our GAN, like final GAN, how we can combine two model together and how we can make composite model. Okay. Now let's take 5 minutes of break. Yeah, I will share. I will share after completing. Okay. Guys, am I audible? Is everyone back? Hello, everyone. Am I audible? Okay. Now we have seen our this one, our discriminator or generator. Okay, like how they are working. So now basically what I need to do, I need to combine these two model together. Okay, I need to combine these two model together, and I need to make a composite model. Okay, so now let's do it. So what I will do, I will define one GAN model. Okay, so what it will take your generator model, it will take your discriminator model. Okay, now here first of all what you need to do, you need to give discriminator model trainable is equal to false, because I don't want to like train my discriminator model weights, okay, during the actual prediction. Okay, so suppose what is happening, let me tell you. Suppose this is my generator model, this is my discriminator model. Okay, the generator model will take one noise data. Okay, it will give to discriminator, it will also take the real data. Okay, real data, and it will predict 0 or 1, that means fake or real. So if it is fake, it will go to here, do the back propagation. Okay, this is my composite model. Okay, composite model. Okay, and discriminator model can be defined separately, as I already told you. Okay, generator also can be defined separately. So whenever I will run my composite model, at that time I don't want to train this discriminator model, because discriminator model will know something, right? Okay, when I want to train, I want to train when my epochs will start. Okay, suppose my epochs has started, at that time I will train my discriminator for the first time. Okay, then I will call my composite model. Just consider composite model is different. Okay, and this model would be different. Okay, so whenever you will be calling the composite model, at that time you won't be training this one, your discriminator. Only you will be training the generator weights. Okay, and it will only train when your loop will start. Okay, let me show you what I'm trying to say. So this is my GAN model. I'm making trainable is equal to false. Sequential I'm defining. I'm adding first of all my generator. I'm adding first of all my discriminator, because as per the image you can see generator is first, then your discriminator. Okay, now I'm again taking Adam as my optimizer, because research has proven Adam is working fine. And loss wise I'm taking binary cross entropy. Okay, because it's a classification. Okay, at the end it's doing, or you can say most of the time binary cross entropy will work fine. Okay, they have proven. Okay, now let's return. So now let's define this architecture. Okay, so first of all I'm taking my latent dimension. Latent dimension will take your this one, your generator. Okay, and this is my discriminator model I already defined. I think you remember here, discriminator model I defined. This is generator model, and this is my discriminator model. Okay, these two model I have already defined. So here actually I'm trying to combine, I'm trying to making a composite of two model. Okay, then this is my discriminator, this is my generator model. Okay, then define GAN. This one I'm passing these two model, generator, discriminator. Then I'm like seeing the model summary. That's it. Okay, these two model I have combined together. Okay, so now this is the actual training loop. Okay, this is the actual training loop. Now inside training loop, what is happening? Okay, so inside training loop, this is the same thing will happen. So let me discuss here. Here, if you see, first of all, what I'm calling my generate real samples. Okay, then I'm training my discriminator model. Guys, can you see? Just see carefully, because I told you my discriminator will train when my for loop will start. Okay, I'm training my discriminator. Okay, now my discriminator model, this model will know something. Suppose 50%, 5% it has learned. Okay, now what I'm doing, I'm generating my fake images. Okay, generating fake images means what? It is generated by your generator model, right? Because generate fake image, I think you have defined here. Generate fake image. Somewhere I think, see, generate fake image, and it is generated by my generated model. Okay, see, I'm getting. And then what I'm trying to do, I'm trying to train on my my discriminator. Again, I'm calling my discriminator and I'm passing this fake data. Okay, now after training, after this for loop here, it has know something like 5% at least is no. Then after generator is passing something, some generated data, it is matching whether it's a fake or real. Okay, if it is fake, go here, do the back propagation. Okay, not here, not, it will be upgraded here, it will upgrade here. Okay, when it will upgrade here, it will upgrade here at that time, for the first time whenever you are calling your discriminator model. Okay, and whenever you are calling your second time, at that time you are not upgrading the weight, you are upgrading the weight. What you are upgrading the weight for your GAN model. Okay, so GAN model, I think you are defining here somewhere, this is the GAN model. Okay, so this is the for loop it is doing. That's it. And after every 10 iteration, you are trying to print the output. Okay, you are trying to print the output. There is a summarized performance. Okay, there is the evaluation function you need to write. So this is the evaluation function. So it is basically, it is evaluating your data, it is giving some accuracy score. Okay, it is after 10 number of epochs, it is saving your model as H5. Okay, and what it is doing, it is also saving the image, generated images it has like generated. Okay, generated.png. This is the function save plot. See, if you see here, I'm calling the save plot in that function only. Okay, these are some helper functions, just consider. It will save your plot, like the generated image it will generate. Okay, it will save it, and it will save the model after 10 epochs here, if you see. Okay, so that is what I'm doing. So this is the entire training loop. You can see, if you just see, I know like it might look some a little bit complex to you, but what I will suggest, after the session, just try to re-execute the code. Okay, try to understand. Okay, because I told you implementation GAN is like a little bit hard. So first time it might create an issue. Okay, always relate with the concepts. Okay, you have learned. With that, try to relate the code. Okay, it would be easy then. Try to at least go through the code. First of all, I'm calling my generate real samples because I need my real samples. After taking the real samples, what I'm doing, I'm calling my discriminator model. First of all, what I'm doing, I'm training my discriminator on a real sample, right? I'm discriminator model. I'm training on my real data. Okay. Once it is trained on real data, I'm again generating my fake, okay, fake images. Again, I'm calling my discriminator. Okay. Basically, what I'm doing, the same way, like I used to do the batch training, right? I showed you whenever I defined the discriminator. Again, I'm taking the fake image. I'm training my discriminator. At that time, this weight is upgrading. Okay, it is knowing. Okay, like it's a real image, it's a fake image. Okay, at that time it knows something. Suppose 5% it has learned. Now I'm calling my what? Okay, generate latent points. Latent points means you are passing the noise to your GANs. Okay, GANs. Your GANs will give you what? It will generate some images. Okay, that images actually X GAN and Y GAN you are passing here in that model. If you see that model, okay, this model, and you are getting the GAN loss and all. Okay, this is just printing. That's it. one questions why we generate two image fake data, one with discriminator model and one with the generator. No, we don't generate like fake image always. We generate, see, it's not a fake image, you can't say. Suppose whenever you're generator, it's generating something. Okay, suppose it has generated one image. You can't say always it would be fake, because whenever this loop will be running, training loop, at that time it will be keep on upgrading the generator weights. At that time, there would be a position it would be able to generate the real image. Okay, whenever it is real image, that means what? Okay, suppose this is your discriminator. Real is what? Real is 1, 0 is and 0 is fake. Okay, so whenever it is a real, okay, suppose it is already trained on real and fake images. Okay, it already knows. Whenever it is real, so at that time, what it will return? Okay, it will return 1. Okay, and your actual is also 1. So loss is close to 0, right? But if it is 0, that means it's fake. That means this is 0 and this is 1. That means there is some loss. Okay, that's actually it's upgrading the loss, guys. Try to just think it carefully. I know it's a little bit difficult to understand, but at least try to like understand. Okay. Okay, now let's start the training. So I'll run one by one. So this is just a summarized performance. I'm calculating the accuracy. That's it. And it is saving the plot. Now I'll call my train. It will take lots of time. I just ran around 20 epochs. It took just 40 minutes for me. Okay, 40 minutes for me. So it will take I mean, a little bit of time from you. At least, see, I'm training around here. If you see, at least train 200 epochs. Okay, 200 epochs. You will see it would be able to generate something for you. Okay, generate something for you. So what I did, I already trained this model around 20 epochs. Okay, and I generated some of the images. Let me show you. So this image is generated from my GAN. Okay, see, it's like very low resolution, but at least you can see. Okay, at least you can see it's some kinds of nature, tree. Okay, some animals. Okay, it is able to generate, guys. See, okay, although it's just 20 epochs. Okay, it is able to at least learn from the noise. Okay, like how to generate the data. And if you do it for multiple epochs, like 300, 400, 1000, the more epochs you will be doing, the more realistic image you would be able to generate from the Shepherd 10. Okay, this much row resolution because I saved it using subplot, that's why. But for you, you can save it as 32,32 by 3. Okay, because I did a subplot. I saved around 40 images together. That's why. You can see it's a little bit low resolution. Okay. I will show you like the prediction code I will show you. Okay. Now see, it has also saved one model for me. Okay. After 10 epochs, H5C. After every 10 epochs, it will save one model, one generated images for you, like how your model is performing. Okay. Now see, it was, I taken one snapshot. Okay. See, it was 20 epochs. It has saved one H5 model and it is also saved the generated. Okay. Yes, I will share the collab link. Just let me complete the code. Okay. See, it was taking very much time because at least you need good GPU to train. Okay. As I was using free collab, and for training GAN, actually you need more good configuration PC and you need more time. Okay. Because generator is, see, it start from noise data. Okay. For that noise data, it will convert to the realistic images. Okay. See, whatever I have discussed, if I show you here, there is a website, GAN Lab. I'm sharing. Okay, now just try to see. If I start here, now try to relate, guys. See, it is taking noise. Okay, your generator is taking noise. It is trying to at least provide some image. Okay, at least like generating something like a sample, fake sample. Okay, so your discriminator is taking your real sample and other fake samples. Okay, Based on that, it is trying to classify real or fake. Okay, if it is fake, generating loss it is getting, it is going here gradient, it is upgrading the weights. Okay, and also discriminator loss it is providing, like the first, whenever a loop is running, at that time your discriminator is also training, also where upgrading is happening. Okay, now if you see, the more epochs you are training, this data and this data is becoming similar. Just tell me, guys, can you able to relate? What are the theory you have learned till now? Just see the picture carefully and try to imagine in your mind. Just look here. See, your generator is trying to make something, okay, like your real image only. See, this pattern and this pattern is almost same. Just write yes or no, guys. Are you able to relate or not? Anyone? No response I can see. Yes, clear. Just try to see here. It is taking noise. Okay. It is taking noise and it is generating some samples. Your discriminator is taking the samples. It can be fake or real, anything. It is taking also real image. It is doing the classification real or fake. If it is fake, generator loss it is getting. It is doing the back propagation. It is upgrading the generator weights. Generator is learning how to generate again. It is also generating discriminator loss. It is again upgrading the weight. Okay, that's how you can see this data distribution and this data distribution like are very similar. Okay, it's becoming very similar. Initially, if I stop it and if I like refresh, I mean, see, if I do reset here. Okay, now if you see, these two distribution are not matching. Okay, these are different. Now if I again start the training, now you will see slightly it will go to this distribution only. Okay, because suppose this is a dog images I am passing, it is also trying to generate some dog images. Now you will see this distribution and distribution will be closing together. Just wait, sometimes you will see the distribution here. Yeah, Bhabia, what's your request? Yes, PyTorch you can do also. Okay, but Keras, it's like a little bit easy to understand. That's why I showed using Keras, because I told you, like, understanding the concept is like very easy, but implementing the GAN it's like a little bit hard. Okay, but you don't have to implement your own GAN because already GAN are there. Okay, I already showed you this GitHub. Already pre-trained model are available. Okay, you just take it and do your job. Okay, as per your requirement. If you want to generate person, use style GAN. Okay, if you want to like you can say increase the pixel size, suppose there is another example here. See, suppose you have face frontal view generation also. Suppose you have side faces. Okay, and you want to generate the entire human faces. Okay, like how he looks like. So you can also do it using the GAN. The pose like generation is also there. Suppose there are many company, they needs model, okay, for their product. So instead of hiring them, you can also generate using GANs. It is also possible. Photo to emojis, okay, it is also possible. Then real image, blondie, okay, suppose see, you can attach here, you can like change some faces. Okay, see, this kinds of apps is also there in your smartphone. Okay, then if you see here, you can also add breed. Okay, then see, this is one amazing work. Like there is a rain, okay, and this image is not clear. Applying GAN, actually you can remove the rain and you can make the clear of this image. Okay, it is also possible. So yeah, there are many tasks actually of the GAN. Okay, you can explore. Yes, thus major concepts inside the GAN, this only. Okay, rather than they have added some of the modification as per their requirement, but behind that actually it is working like that only. They have discriminator, generator is keep on generating something, discriminator is checking whether it's correct or not. Based on that, it is doing the back propagation, and there is a time whenever generator is able to generate something realistic. At that time, you are taking the generator model and saving it as a HPy file. I think I showed you. Okay, here. Okay, and you are using this generator model to generate something. Okay, now let's stop this execution and let me show you the prediction, how to do the prediction. Okay, for you just train multiple epochs. So what I will do, I will upload my model. Okay, because I already trained this model, I will upload here. Because see, this is just 10 epochs I trained. Okay, this model is not that much of good, but at least I will show you the prediction code, like how to do the prediction, how to load the generate model. So I'll comment here. Generating after training. Okay, how to load the model. So this is the code. Basically, you are not doing anything. You are loading your model, generate latent points. That means you are giving noise. Okay, that noise is predicting by your model, your generated model. It's giving the image. Okay, now let me run and show you. And I'm sharing this notebook with you. Just let me know, is it accessible or not? See, audio, video, you can do it, but again, audio data is like, you need like good configuration PC. Again, you need to do some, what I can say, like cleaning inside the audio, like you need to convert this audio to the frequency, then number. Okay, you need to do some processing, then you can use. Okay, it's a little bit lengthy task, but at least you got the idea. Like, see, now I think you know like how GANs work. Okay, and what is the concept behind it. Here I am passing image, you can also pass audio, videos. Okay, it's up to you. Okay, and you don't have to train your GAN model, because see, it's not required, because if you see, there are many GANs is already available for you. Okay, and mostly you won't be using GANs. See, in industry I haven't seen like people are using GANs. Okay, it's like if you have interested in this. Okay, at that time you can explore, but in industry actually nobody uses GANs. Okay, but for your task, suppose you want to generate some data and all. Okay, you want to do some experiment, at that time you can use it. See, my model has been upgraded here, so just copy the model path and paste it here. Okay, now let's run the code. Now what it will do, it will generate image. See, it's like not good, because it's like just 10 on 10 epochs. Okay, now again, if you run it, it will generate some other image. See, okay, if you just do 200, 300 epochs, you will see something is generating, some animal, some boat, some aeroplane, it is able to generate. Okay, see, it's generating something. See, at least it has some relation. Okay, first of all, how it was looking like, it was just a noise. Here, if I show you, see, it was just a noise. Okay, after training it 20 number of epochs, it's like able to make some pattern. Okay, so that is how actually neural network works. Okay, just always consider with your human brain. Okay, so that is the concept. Guys, I think you got it, the GAN concepts, how it is working and all. I will suggest just go with the notebooks, try to run it from your side. Okay, and if you are confused, just try to watch the recording again, so it would be clear. Any questions, guys? If you have any questions, you can raise your hand. Anyone? Any questions? Yeah, Bhabya, what's your query?
Yes, sir. Can you hear me?
Yes, I can hear you.
Yes, sir. Previously, I write in the chat, no, like we are providing some images to the model, and then it is generating some fake images, and then we are predicting like it is fake or real. But the machine is only creating the fake images, then how would I get to know that this is fake image or this is a real image? Like I'm providing, if I'm taking a dog image from an internet, okay, I know that it is a real image. And if
Hmm.
it's considered like it's a fake image, then means how I will get to know that?
See,
Uh,
for that there is a discriminator, na? Like discriminator is what? It's a mentor. It knows already. It knows like how your real image looks like because it is trained on real image data. See, okay.
yeah, that I got.
Hmm. So what is basically will happen? So real image it is also training. Fake image it is also training. That means it is know like what is real and what is fake.
Okay.
I think I showed the first example. It is able to classify very easily, right? Because the
Yeah,
distribution
yeah.
was see different. Okay, now whenever, because see, suppose you have passed dog images, so dog has some distribution if you convert it to array, numpy array, right? Okay,
Yeah.
so your generator will generate some the same thing. So
Mm.
suppose it is close to dog, this array and
Okay.
this array, okay, correlation would be very high. Okay, just consider the correlation very high. At that point of time, the loss would be zero, close to zero, right? Suppose 0.0.36 around. Okay, at that point of time, see, it's not like 0 or 1 because at the backend it will
Mhm.
convert 0 point something and all. Okay, and whenever it's closing to 0 at that point of time, this array distribution and this array distribution is matching. Okay, whether it
Mm.
might be different, say, I mean separate dog also, but it is a dog, right? Okay,
Yeah.
it has 2 ears, it has 2 eyes, it has one nose, it has
Mm.
also one nose, right? So that's how actually your array would be, will have the correlation same. At that point of time it will get to know, okay, it's a real data. Okay, at that
Okay.
time output would be also 1, and then 1 minus 1, what will happen? You will get 0. That means there is no loss. That means no need to upgrade the weights to the generator. Okay,
Okay.
at that
Okay.
time your training is done, you will take the generator out. Okay, you will save it as h5 format and you will use it.
Okay.
Got it?
Yeah, yeah. Once I will try, then I will get the whole
Yes,
concept
yes.
clear then.
Mhm.
Okay. Thank you.
Okay, okay. Yeah, Anishwadash, what's your query?
Actually, sir, I have one doubt regarding another issues. I have already mailed you.
Okay, which one?
Actually, Sani Bhavin Chandra sir has told one top cat related classification. Actually, I have doubt on that
Okay,
particular.
dog cat classification, like you are getting any error or what?
Yeah. Actually, the requirement file is not installing in when I use the neural app.
Okay, so do one thing. I think tomorrow is your doubt clearing session, right? Wednesday.
Yeah.
Okay, so join tomorrow
Sir,
at
tomorrow,
8 p.m.
sir, 8 p.m. Okay.
Okay,
Are,
because
are
see,
you there? Are you there?
mostly I will be there. If I'm not there, I like there is another person, Rishabh Dash. I think you know. He's also he's my colleagues also, so no issue. Like both can handle. Okay, no issue. Mm,
Okay. Rishabh sir
okay,
will be right.
Rishabh Dash would be there, and Vikas sir would be there also. I think. Okay,
Okay, sir.
because mostly I will have week off tomorrow, because tomorrow is my week off.
Sir,
So,
can if you check, it would be better for
okay,
me.
no issue. Then if I get time, then just send me a mail again. I'll connect with you. Okay, with a different mail. With a
Okay,
different date.
I already sent mail
Okay, what's your name?
on Nishatash.
Just give me your mail address in the chat. Yes, this model, it has generated, right? The generator, it is already trained. You can use it
Okay.
for generating the images. Okay, I think I already showed you at the last. Yes,
Sir,
you can drop, guys. Like, session has
yeah.
been over.
Sir,
Okay.
I have been.
Yes, I got it.
Sir, can
Okay.
I? Sir, actually, I have missed some classes.
Hmm.
So
So if you have missed some classes, then you should at least finish it because every classes is related to other class. Okay,
yeah.
so that's why it's required.
Okay.
Okay. Okay. Hmm.
Yeah. Sir, please check if you
Okay,
get.
okay. I think I send you one mail also. Okay, I will check it.
Okay, okay. Thank you, sir.
Okay, guys. So if you have doubts, so just join your doubt session. Okay, and try to do it from your side. Then it would be more clear. Okay. So how was the GAN concepts, guys? Like, did you liked it? The way this young good fellow taught the concept. Okay, although it was a simple concepts, but still, like, it's like very powerful. Okay, guys. So good night, everyone. Let's drop up. Let's meet your